Today's lesson will be fairly short. It's going to be about the physical states of matter. You may already be familiar with these physical states of matter, but there are just another way that we can organize matter and categorize it. We've seen that matter can be considered pure substances, which are either elements or compounds, or mixtures of two different types, homogeneous or heterogeneous. The physical states of matter are solid, liquid, and gas. You might already have studied these in a previous science class, and we're all familiar with all of these states just from ordinary everyday life. Pure substances can exist in any of these states, and they can change from state to state depending on the conditions that are around them. The first physical state we'll look at is solids. Things that are solids have a definite volume and they have a definite shape, like this bar of gold. This gold will always take up the same amount of space, and it will always have exactly the same sort of three-dimensional trapezoidal shape that you see here. And it wouldn't matter what container I put it in. I could put it in a bucket, I could put it in a beaker, I could set it on the floor, and it would always have the same volume and the same shape. Liquids have a definite volume, but they don't have a defined shape. So if I have 300 milliliters of liquid and I put it in a test tube, or I put it in a beaker, or I put it in a flask, or I pour it on the floor, it'll always be 300 milliliters. Its volume is defined, but its shape will be whatever shape the container is that it's in. Gases are different from both solids and liquids. Neither their volume or their shape is defined. For example, if I have a spray can full of something like Lysol or a room deodorizer, all of the gas that's in that can is compressed inside that space, that volume of that cylinder. If I push the cap down and I spray that out into a room, well, it now fills up the room. It has the shape of the room and the size of the room. Its volume and its shape both depend on what container it's in. The physical states of matter can change for a pure substance and even for some mixtures. We have names for all these changes of state, and they all involve energy. For example, when a solid becomes a liquid, we call that melting, or another fancy word for that is fusion. When this happens, the substance has to gain energy, and so we're looking at a bottle of champagne here being cooled by the ice. It's being cooled by the ice because the ice is gaining the energy that was in the champagne. That's how that works. Just the opposite process is freezing. Freezing is when liquids become solid. This is a loss of energy. It's an exothermic process. Exo means out, and therm means heat. So this is a heat out process. In order for something to freeze, it has to give up heat. Now that seems a little counterintuitive because we always think of freezing as happening when it's cold out. But the freezing isn't making it cold out. It's freezing because it's cold out. There has to be a place that's cold for the energy to go into in order for freezing to occur. Vaporization is when a liquid becomes a gas. Well, this is a process that requires energy. Anybody that's ever boiled water knows that you can't do it unless you turn on the stove or put it over a fire. There's another process that's less familiar to people from ordinary everyday life, and that's called sublimation. Sublimation is when we go from a solid state to a gas state directly without melting. Here you can see a picture of some iodine doing that. It's going directly from the solid crystal phase to this purplish gas. It requires energy just like vaporization to do this, so it's an endothermic process. This actually does happen with ordinary water when it's in the form of snow. In the wintertime, there will be stretches of time when it never gets above freezing for a couple of weeks and it doesn't snow, and you can see the level of the snow go down. Partially that's because the snowflakes are collapsing into each other, but it's also because there's some sublimation going on. Condensation is when a gas becomes a solid or a liquid. And this is a process that loses energy, and so it happens in places where it's cold. Like, for example, high in the sky. This picture is showing the contrail of a jet. The gases that are coming out of the back of the airplane's engines are very hot. It's very cold up there. It's about 50, 60 below zero where commercial aircraft fly. And so the gases, mostly water, immediately condense into liquids, and you can see them. Another place where this happens is on the outside of a cold beverage, a glass of soda or ice water or iced tea or something like that. It's always wet on the outside, and people say that it's sweating. But we know that that's not coming through the glass. Otherwise, we wouldn't use glass because it would be leaky. So what's really happening there is the cold beverage inside is cooling down the air, which contains water vapor, gas, and it condenses to those little drops that we see appearing on the outside.